right, welcome everybody to another episode of Hoot, where we are going to discuss Hitless Deploys using Envoy Kubernetes. And we're going to talk about how we want to do it, why is it problematic. We're going to have a little slideshow and then a little demo. And I also want to, once I do the demo, I actually have some questions to our viewers about how you want to see demos going forward. So please stay for the demo so we can get that answered for you. So we do this episodes every 2 weeks talking about cloud stuff, and without further ado, let's get started. So I prepared a little presentation here talking about Hitless Deploy, and again, if you have any questions, as per usual, Hoot, feel free to ask them in the chat and I will answer them live. So let's start with our goal. What are we trying to accomplish? Right, so our goal is to keep the user happy, and specifically keep it happy when things are changing, right? So if we have a cloud setup with a load balancer sending traffic to an edge gateway, in our case we call it Envoy, that sends traffic to services. Every time we roll out a new service, or even when we upgrade the edge gateway Envoy, we want the user to keep getting 200 OKs to the user's request, right? We don't want the user to be ever sad and every request turn into 500 instead of 200, right? So presumably it looks simple, but because of all the moving parts, it gets a little bit more complicated. So the general strategy is to have each component in these layers that we just discussed understand the state of the components they depend on, right? And usually to signal components that you're about to go down and another instance is about to replace you, we can use health checks, and we can combine that with some retries, and we'll see a bit later in the demo exactly how to do this with Envoy to recover from network failures without letting the user, propagating it back to the user as a 500. So a little bit more into details, right? We have all these layers. We have the user, which is essentially an app or a website that's sending a request to the cloud. These requests get into the cloud load balancer, and cloud load balancer sends them to the edge of our Kubernetes cluster. In our case, that's going to be an Envoy proxy that then sends them to a Kubernetes service, right? So in this case, when we talk about making sure that there's no hits, right, that everything is flowing, we can say that, okay, what can each layer do? Right, so the user can, or the app can perform several retries if a request is failed before showing an error to the user. The cloud load balancer can perform health checks on the edge gateway to know which instances of the edge gateway it can use. And the edge gateway can in turn perform health checks and retries on the services to know which instances of the service it can use. And now I'm going to go into a bit more detail, and I'm going to show some a mistake, kind of common anti-pattern, and then what can we do to make it right. So now, essentially, we need to make sure that each layer understands the health status of the layer below it, right? So we need to configure Envoy with health checks to understand the health state of the pods that it sends traffic to, and we need to configure the load balancer with health checks to understand the health of those Envoy instances that it sends traffic to. Now, why is it a bit hard than what you would think? So the load balancer, the edge gateway, Envoy in our case, and the services are decoupled from each other. So most cloud load balancers are not Kubernetes aware, and Envoy is also not Kubernetes aware, unless the control plane bridges that gap. So you gotta understand the layers in order to understand how to make it in such a way that it would work. So let's first talk about the cloud load balancer to Envoy direction, right? So the user sends a request, it reaches the cloud load balancer, and the cloud load balancer sends it to our edge gateway in our Kubernetes cluster. In our case, we're talking about Envoy. So the cloud load balancer needs to know the health state of Envoy. The problem is that cloud load balancers are usually not Kubernetes aware and are usually designed to work with virtual machines or auto-scaling groups. So let's give an example on how not to do this. So let's say we configure our edge gateway as a node port service, and we can configure our cloud load balancer to send traffic to the Kubernetes node port. Right? What's the problem in this approach? The problem with this approach is that if cloud load balancer, what it sees, it does not see Envoy, right? It sees all these Kubernetes nodes and their node port. And each health request that gets to a node in Kubernetes can reach any of the Envoy instances because they're distributed kind of randomly. There's also ways around that, but never mind right now. Right? So essentially this is not going to work, right? Because if I go back to remove that X, because the load balancer sends a health request to node 1, it will get the health status of randomly either Envoy on node 1 or Envoy on node 2, right? So it makes the health information useless. And again, it's kind of because the cloud load balancer is not Kubernetes aware. So essentially, if you're using a node port to expose your edge gateway to your cloud load balancers, you cannot just naively use health checks because they will mix and match on the different pods and essentially become meaningless, right? So what to do then if we're not going to do that? So you have several options. In GKE, you can use a cluster that's with a native VPC cluster, and that essentially makes the load balancer aware of the individual pods. Each pod will get its own routable IP, right? So if your cloud load balancer can be made Kubernetes aware, that's great, and it essentially you don't need a node port service anymore. Another option is that if you have to use a node port, you kind of have to make sure that the association of a Kubernetes node to an edge gateway pod to Envoy is 1-to-1, right? And you can do that with either a daemon set with host port or host networking, or we can talk about different deployment methods where you deploy at most one pod to one node and use external traffic policy local on the service so that kuproxy only sends requests to local pods, right? So that's to solve the health correlation problem with the cloud load balancer. Another thing you need to do is configure the health check filter in Envoy, and we'll show you how to do this in the demo, in order so that Envoy replies to health check requests. All right. So up until now, if there's any questions, feel free to ask. Are everybody seeing the presentation okay? Feel free to drop a line in the chat, say hi. That makes sense. If you want me to go a bit deeper or anything. All right, so that's kind of the short version of the hitless, health checks and hitless deploys between load balancer and the edge gateway, right? If we mess up these health checks, the gateway might mistakenly think that one of the nodes is not healthy and will route less traffic to it, even though it's only a specific pod that's not healthy, right? And traffic will still get to that, and we get 500s, right? So if I go to this diagram again, let's say that the load balancer, because of this erroneous setup, thinks that node 1 is not healthy. They'll send requests to node 2. They'll still make it to the Envoy on node 1 that's coming down, and the user will still get 500, right? And that's why we need all these strong correlations between the health check performed by the load balancer and the Envoy pod. That's essentially the goal that we're trying to achieve here. All right, so let's talk about the other segment of Envoy to the upstream. So the request made it from the load balancer to Envoy. Envoy did some processing as an edge gateway and now sends it upstream. So in order for that to work, Envoy needs to know the health state of the service pods, right? So Envoy is not aware of Kubernetes readiness and liveness probes, right? So even if you defined a readiness probe and the readiness probe fails as the pod terminates, Envoy is not aware of that. Unless the control plane makes Envoy aware of that, Envoy will not be by default aware of that, because Envoy is kind of infrastructure agnostic, right? It just does the data path and it lets the control plane give it the details it needs from the infrastructure. In addition, you got to remember that in a distributed system, the view of each component in the system of the system state is eventual consistent, right? So if a pod tears down, it takes time for this information to propagate to Envoy, right? So even if you have a control plane that takes the Kubernetes information and sends it to Envoy, it's still, you cannot rely on this happening instantaneously, right? And let me, I have this animation, I gained some animation skills in here to kind of understand, to kind of relay the point. All right, so let's talk about a failed attempt here on how we want to do a rollout for another pod in this deployment. So let's say we have Envoy, and Envoy's view of the state of the cluster that it has two endpoints. It has 10.0.0.1 and 10.0.0.2, right? Now what we want to do is we want to kind of do a rolling deploy another pod, and remove one of these pods in our deployment. So now we deploy this v2 pod with IP003, and we delete the previous pod as part of the rolling deployment, right? Now, because the system is eventually consistent, there's gonna be a little bit of time until this information propagates to Envoy, right? It might be half of a millisecond, but or more realistically, it's probably going to take a second or two, but it will take a non-zero amount of time for this information to propagate. And during that amount of time, you will get 50% of the requests will fail, right? And if you have 1 million requests per minute, that could translate to a good amount of errors, right? Eventually, the information will propagate to Envoy and it will send the request, but it might take time. Now, it's especially true if your deployment is small and if you don't have any retrans configured, and you might see this problem manifest even more, right? So the way to overcome this problem is to make sure all these components kind of give a little bit of wiggle room to allow the rest of the components that depend on them understand that they are about to go down. And that's where the health checks and retries coming, right? So this obviously doesn't work because we get unhappy users. So what do? When a pod terminates, Kubernetes sends its sig term. Instead of exiting immediately, the pod should allow some time to drain connections gracefully, right? So for example, maybe for 30 seconds, the pod should just stay there and keep processing the existing connection, and at the same time signal components that use it to stop using it. And the way to do that is to fail health checks, right? So let's say the pod serves health checks on /health, and normally it returns 200. Once it gets this sig term, they need to start returning 500. So dependent components, Envoy in our case, for example, knows that this pod is about to go away, and it should stop sending traffic to that pod, right? So if there's any questions, feel free to write them in the chat. I know it's a lot of information I'm giving up all at once, so please feel free to pause me anytime and ask if anything is unclear. Right, so the basic idea is kind of when you're building two parts and you want to put them together, you don't want it to be too tight of a fit, because then they might not work. You want a little bit of wiggle room, right? And that drain period is that wiggle room, right? So the pod, instead of terminating immediately, hangs around for a bit, fails health checks, let dependent component know that it's about to go down, and after that drain period is over, then it exits, right? So on the Envoy side, we can configure health checks and retries to essentially process that drain and understand that drain period from the pod. Now, a service mesh can automate some of this. It can actually add health checks that fail automatically. So that's also something to explore. If you don't want to rewrite all your application code everywhere, maybe a service mesh can help you, but do your own research on that part. All right, so let's talk about what we're gonna see in this short demo. I'm just basically gonna demonstrate Envoy talking to two services and them being deployed, and after that we'll review the Envoy configuration and see how we made it to work with a hitless deploy. Now, the question I wanted to ask about these demos, usually I like to keep these demos kind of local, that everyone can run them on their laptop without Kubernetes. But I'm not sure, maybe in this case it'd be more valuable to do a demo on Kubernetes with deployments. So if you have any opinion on how these demos should go going forward, please leave a comment. If you prefer a demo that you can hack around yourself and change and not need a lot of stuff to run, or do you prefer more realistic demo on Kubernetes, on kind, that you can play in a cluster environment. So either leave it in the chat here or leave a comment and tell me kind of which demo directions you think I should go with. All right, so with that, let's change it to VS Code. So first let me review this kind of service environment that I've created. So what we're going to do here, first we're going to start service 1, right? And service 1 returns 200, just so we can tell the difference between it and other services. We're going to let Envoy know that the service was deployed, essentially update Envoy EDS information with the endpoints of that service. Then we'll deploy service 2. Now, unlike service 1, service 2 drains when it terminates, but service 1 does not drain when it terminates, right? Then we'll exit service 1, update the information that service 1 disappeared, and do the same thing with service 2, and then see the difference between a service that drains and a service that doesn't. So first thing first, let's start Envoy here in the background. All right, we have Envoy running, that's a connection failure, that's fine because the control plane is not running. Let's run the control plane, so there's no complaints. Here we go. Oh, sorry, here we go. Okay, clear the screen. Perfect. So Envoy is connected, everything looks good. All right, in a second terminal here, realistic with Kubernetes. Thank you for that. I'll try to make the next suits more cluster with YAMLs and Kubernetes and kind. One sec. So now what I want to show is we're gonna run hey and issue some requests. Now you see service 1 is responding with 200s. Everything is good. Nice. All right, so now I'm gonna just hit enter here, and we're gonna see what happens when service 2 is deployed and service 1 is being teared down without any draining to service 1. So it's deploying service 2 and removing service 1. And as you can see, I don't know if you saw, it was pretty fast. We had some fail requests, and just to show you that fail request, you can see that we had 100 500s. So we had 100 failed requests because of that eventual consistency, because it takes time for the information that service 1 disappeared propagate to Envoy. And in the meantime, Envoy might keep sending requests. Right, so let's get back to hey, and we'll deploy service 3 and tear down service 2, but this time service 2 has draining. Alright, so you can see it's deploying, publishing the endpoints, and service 3 is now deployed. And let's revisit that metric. And you can see that the metric did not increase, right? It's the still original 100 500s. We did not have additional 500s when we deployed service 2. Now all this code is in our GitHub repo. There's a link in the description, GitHub solo.io hood, so you can look and play around with it. And in the next demos, I'll try to make them more in a Kubernetes environment. But you can see exactly how the draining works. I don't want to get too much in the weeds right now. But the idea of this demo is showing you how this draining period just saved you 100 failed requests, right? Because we allow Envoy to understand that the service is about to go down. Because of all these moving parts and because everything is eventually consistent, we do need this a little bit of wiggle room. So let's, before we look at the Envoy config, one more thing. When we talk about the load balancer part, Envoy can expose health checks on its own. So let's look at these health checks. So it's configured to use /health, and you can see that it returns HTTP 200 OK. Now what we can do is to tell Envoy to fail its health checks, and the way we do it, we go to Envoy's admin endpoint, and we call, using a post request, health checks fail. So you can see curl post, 8001 is the admin port, health check fail. And then once we tell Envoy to fail its health checks, once we curl it, we get 503. And that's how we can signal to the load balancer that's querying Envoy the status of Envoy itself. Alright, if there's any questions on what you just saw, please feel free to ask now. Then in the meantime, I will review the Envoy configuration that I used in this demo. Right, so it starts pretty normal. Things get interesting right here. So the first thing you can see that it's different than a normal vanilla config is there's a retry policy defined on the virtual host. And what I'm telling it is to retry on all of these network error, right? The common thing with this error, they're usually not application specific. They're usually because of some timeout, some network error, some connection refused, connection reset, not a bad request, right? So these are network errors, and I grabbed that list from the Envoy documentation, and in the README, in the repo, there's a link to the documentation where this appears. And essentially we say do 5 retries and make 5 attempts to select a healthy host to retry to. And I see we have a question in the chat. How does the pull ejection initio work? So I'm gonna get to that. So circuit breaking is something a little bit different. We're not going to cover circuit breaking here. We are going to cover in just 1 second health checks and outlier detection, which is in the cluster definition down below. So if you still have a question, this question after I review that part, please feel free to ask it again. Okay, so this is first part, the retry on network errors. And that's defined in the virtual host or the route level configuration inside the HTTP connection manager. Right, so that's one part, and that will happen to the reason we define it here, because that's a property of the request, whether we retry a request or not. When we're talking about health checks, that's a property of a pod or a host, and these will be defined on the cluster, which we will review now. So essentially, health checks are used to tell us which host of the cluster is healthy. Right? So if we look at the cluster definition, we can see that it gets the endpoint from EDS. That's how I made the demo dynamic. And we can see we have 2 parts here. One, because it's a small number of endpoints, I disable panic mode, otherwise the demo wouldn't really work correctly, but we'll ignore that for now. If you want to learn more about panic mode, feel free to read about it in the Envoy docs. There's two sections or two health checks configuration that are interesting in a cluster. There's passive health checks and active health checks, right? So outlier detection is the passive health checks. And what that means, it means that Envoy observes requests going to a certain host and observe the responses. And if Envoy sees 3 consecutive 500 response codes, it considers that host not healthy, right? And it's called passive because for this to work, there needs to be traffic, right? There needs to be traffic from the user ongoing to that upstream cluster, right? So Envoy does not initiate anything here, right? If all of a sudden that host goes down, that pod is deleted, Envoy is not made aware by the control plane, Envoy will still consider that pod healthy until it gets 3 consecutive 500s. Right? The second part is active health checks, and those are health checks initiated by Envoy itself, right? And first, the first part is a generic part that is all health checks have in common. So unhealthy threshold and healthy threshold, and those are threshold to after how many successful or failed health check requests do we change the state, the health state of an upstream IP address and a pod, right? The interval in which to do health checks. The interval to do health checks if there's no traffic, you might want the lower interval here to reduce the load on the cluster. I set it to low again for this demo to work more reliably. And timeout, basically the timeout for the health request. Now, because it's an HTTP upstream, we define an HTTP health check. There's a bunch of parameters. I only defined the path, right? So with this configuration, approximately every second, there's a little bit of jitter involved, but approximately every second, Envoy will send HTTP request to the upstream to /health. And if it gets 200, it would consider it success. And if it would get 500, it would consider it failure. And these are all tunable, all the status code, everything. You can review that in the Envoy documentation, right? So to summarize, there are 2 means for health check. First one is the passive health checks, and that's, I believe, what the question from the chat was about pull ejection. That's essentially outlier detection, and the number of errors is configurable, right? So it really depends on your specific configuration, what it is. Health checks are active one where Envoy actively sends requests and queries the health information. And the way this demo worked really is that when service 2 came down, it listened to this health URL and sends 500 instead of 200. And during that period, Envoy knows to stop sending traffic to that service because it's no longer healthy, and only send traffic to the remaining instances. All right, I know that's a lot of info to take in. I'll do one final review of this config, and then we'll wrap it up here. So in this Envoy configuration, we implemented 2 mechanisms, 2/3, to increase reliability and enable hitless deploys. One is retry policy on network errors, and the other is health checks. Here I define both passive health checks, also known as outlier detector, and active health checks. You may not want both of them, you may want one of them, you may want the other. It really depends on your use case. And what this allows to do is essentially, assuming your upstream pod knows to properly signal and propagate health information as you tear it down, this will allow Envoy to process this information and stop sending traffic to the pod before it's completely done. Now, in the case that something happened, the pod crashed, or maybe you cannot change the drain period because you don't control the application pod, you can also add retries to retry in case of a network error and send a request to a different location. Combined, this will up your reliability rate from the edge gateway. I also have what I said summarized in this README. You can see kind of an overview, instructions on how to run the demo, and links to the Envoy documentation if you want to read, more information and understand this a bit more in depth. All right, with that, if there's not a lot of other questions, we're gonna wrap up for today. And again, feel free to join our Slack. We're available there, and feel free to ask us questions. We love to help the community. And join us again in 2 weeks for another live stream of Hood. Thank you, everybody, for joining, and we'll see you soon.